Remember the class A to class E ranges. Okay, IP address, IPv4 address is divided into total range. Where is the total range I have written? Yes, this is 0.0.0.0 to 255.255.255.255. This is like a 4.3 billion IP addresses are divided into 5 classes. Class A, Class B, Class C, Class D, and Class E. Class A 0 to 127 or 1 to 126. Why? Because of 0.0.0.0 is also called as an unknown IP address, reserved IP address for a certain protocols and application related. Okay. And also 0 series, 0 dot something, it also we are not using. And 127.0.0.1 is a loopback or a localhost address. It is a reserved IP address for a localhost or a loopback IP address. And 127 series also we are not using. So that's why it is showing in some textbooks or certain websites it is showing 1 to 126. That complete range is 0 to 127 and the usage range is 1 to 126. The class B 128 to 191, class C is 192 to 293. Okay. So class A, class B, class C are a unicast address. Generally from class A and class B, class C, these IP addresses we can assign to any adapter, either manually or through DHCP. We can assign the IP addresses in the range of class A and class B, class C. We can do it, except that 0.0 to 0 series and 127 series and 169.254 series. We can assign any IP addresses to any adapter. Class D is used by certain protocols. The range is 224 to 239. It's a multicast addressing. Okay, we cannot assign these IP addresses to any adapters. It is used by certain protocols, while the protocol to other like they are doing communication, we are using. Already I explained that one. That's why try to understand. Okay, we don't assign class D IP address to any adapter. We cannot assign. We don't accept also. Okay, so it is used by certain protocols. Class C is not by protocol, not by assigning to adapter. Okay, it is like a R&D type or some development. Maybe in it will be released. Okay, it is reserved part, like it may release in future. But there is a one last IP address. Is a very useful IP address is 255.255.255. Like this, 3, 4, 255s, 255.255.255.255. That is the last IP address in the total IP addresses. That is a universal broadcast. Like I want to send a message to everyone, irrespective of what network it is, irrespective of what network, what protocol it is. The devices, those who are connected, I want to send to everyone, like a broadcast. So I use my destination address, destination IP address as a destination IP address is 255.255.255.255. Okay, so that is my destination address. So right, so that is universal broadcast address. Generally we don't use class C, direct class C address, except that address, all remaining we don't use it. Okay guys, so identification of IP address based on their classes, you can take any example, so you can identify. So check the first octet only and check the cross verify range with the table. Okay, so you can identify which class it is. Okay. So, and here it is again, unicast address, like a class A, class B, class C. We can assign the IP addresses to an adapter from class A to class C. Class A, class B, class C, except 0 series, 127 series, and 169.254 because it's a APIPA series. Okay, and next, so what is the use of this dividing the classes? What is the use of dividing the total IP addresses into the classes? It is like already, as we said, IP address is a logical address, right? IP address is a logical address. To what is the logical address? Very simple. It is what is a physical network and what is a logical network. So for example, this is I have a switch and I have multiple computers are there. Like this. Now this is entirely one physical network, right? Physically, it is a single network. Physically, a single network. For example, same like this, same thing. Like there is a switch, there is a 10 computers are connected. That is a physically another network. Physically another network. Okay. Now, what I want to do is this network address is same like these PCs. Network address is like this, something like a one network address, network part. So these are all PCs network address is same and host address will be changed like a host one, like a roll numbers 1, 2, 3, 4. Guys, look at here. For example, your batch is 5, right? Batch number 5. I am putting a serial number like 501, 502, 503, 504. Okay. So I am giving the roll numbers to you. What is 1, 2, 3, 4 represent? Your roll number. 5 represent, for example, batch number. 5 represent, for example, your batch number. Okay. So 1 second. Okay. I thought it is important call because I got a number. Okay. So same thing. The 5 represent your batch and these are represent your roll numbers. So it will varies, right? But 5 is constant for entire batch. For example, afternoon I have a batch that is N2 batch. N2 batch. Noida 2 batch. So I put a roll numbers 201, 202, 203, 204. So what is a constant? So this is represent N2 represent it's a which batch it is, and this is the roll numbers. This the same goes here. The network portion represent which logical network it is. If network is portion is same for these PCs, there are logically same network, and the host portion is always differ. Host portion can be changeable like 3, host portion like 4, host portion 5, 6, host portion 7. So all these PCs are logically same network. All the PCs, what are the PCs you are looking at, all are physically same network. But the PCs who are having their network portion as the same, so there are belongs to logically same network. For example, this PC, the network portion is N2 like this, just different network portion from here. Okay, N3. we'll put N2. N2 N3, something just like that. So this N2, so we'll put some colors on it. See, N2, N2, N2. So these three are a same network. Okay. This is N3. This is N3, same network. It means this will be communicate each other and cannot communicate with others. These will communicate each other, sorry. These devices will communicate each other and cannot communicate to others. Okay. These species will communicate each other. They won't communicate to others. So logically different. That's why IP address is a logical address. IP address can divide a network into logically. Divide the network into different networks as a logically it can able to divide. Okay. So so class C, class B, class A divides the network into network portion and a host portions. Network and host portion. You can see this is the host portion. So only one single host portion in a class C. Okay. So what is the advantage? So you want to make sure that these species should not communicate it to these species, right? You don't want to make a communication between this network. You don't want that one. And also same thing goes here. You don't want to make a communication between these species. There are some different department. So automatically by changing of IP address or a network address, it is different. Okay. Automatically they won't communicate each other by default. Okay. So that is one advantage of dividing into classes. So then it is a different classes having different network and host portions. Okay. One network cannot be communicated to another network. Logical network cannot be communicated to another logical network. And what is this host portions part? If you take a class C IP address, you take a class C any IP address in this range, you will get only one single octet. This third octet is a host part. Octet means 8-bit, 2 to the power of 8 minus 2, you will get a 254. It means if you are using a class C IP address, if you are using a class C IP address, you are using a class C IP address, you can connect 254 devices. 254 devices. For example, I'm taking a 192.168 10.0. This is my starting IP address. Starting IP address. Okay, starting IP address. This is, we call it as a network ID. So we will identify which network it is. We can identify which network it is. This is a starting IP. It is a network ID. We cannot assign this IP address to any adapter. 192.168.10.1. So this is valid host address. This is also called a first valid host address or host IP. Okay, it means you have a computer or a laptop, you want to assign an IP address. Yes, you can assign this IP address. You cannot assign this IP address to anyone, but you can assign from here. Then it is developed like 1, 2, 3, it keep goes, and we'll get a 254. Up to 254, we can, like a 1 to 254, we can assign. The 254 is a last valid IP address. Okay, valid IP address means we can assign to the any PC up to here. But last one is 255. Okay, originally in the range, last one is dot 255 means 192.168.10.255. Okay, so this one we call it as a broadcast ID. Broadcast ID. What is the meaning of broadcast ID? For example, there is a PC like a 192.168.10.2 and 10.3, 10.4, like that. PCs are configured. One of the PC think they want to broadcast to everyone within the same logical network. They want to broadcast to everyone, but within the their broadcast range, within their logical network. The PC want to broadcast a message. So what they will use, the destination IP is 192.168.10.255 as a destination IP address. It meaning is any device, their network ID is 192.168.10. After that one, whatever it is. Okay, it can be 1, it can be 10, it can be 50, it can be 100, it can be 200, it can be 35. So it will give the message to all the devices. Those devices, first 3 are a same only. So this is one single network. Whenever you change the network, what is the next one is 192.168.11.0. This is another network ID, means it's a new network, means it's a separate network. Okay, this is 10, this is 11. Okay, so automatically it is a different network. Automatically it is a different network. And this is the first IP address in the network. It is a network ID. Next one is become 11.1. Again, in this network, this is the first valid IP. Okay, this and this won't communicate each other. Okay, both are separate logical networks. And here it is, if you see network ID and broadcast ID, we are not assigning, we cannot assign to anyone. Okay, broadcast ID and network ID, we can't assign to any PC. We can assign from 1 to 254. So that is the range it is showing, 1 to 254. That's why -2. Network ID and broadcast ID we can't assign to the host. That's why we are doing -2. Same goes for class B. Same goes for a class B network. Okay. If you take a example for a class B, for example, regular IP address only, I'm taking 172.16.0.0. This is the starting network ID. Okay, and it is continue like this 172.16.0.1. It is a first valid IP address. So you can assign from here 1.2, 1.3, 1.255 is last, and 1.0, 1.1, 1.2, like this. When it is finished, 255.254 is a last valid IPs. The very last one is 255, 255. This is a broadcast ID. And here it is 172.16. This is the last IP address in this series, and the last one is broadcast. Last valid is this one. This is the last valid, and this is the broadcast ID. So network ID, broadcast ID, we can't use it. The next IP address automatically 17.0.0. These zeros, these are zeros. 0 and 0. So automatically the network portion is got changed. This is become another network. Another network. So this is another network's ID. You know, the total IP addresses, which is from here to here or here to here. Okay. So is like this. Two portions are a host portions. First two portions are network portions, and next two portions. First two octets are a network octets, and third and fourth octets are host octets. You know, this is 2 are a host octets. It's a 2 to the power of 16 minus 2, 65,534. Network and host class A. It's same as a class B. Same. First portion is network portion, remaining your host portions only. For example, you take a IP address like this. This is the first one, means it's a network ID. First IP address which we can able to assign in this network is 1. And it goes 1, 2, 3, 1.0.255. Next is 0.255, 1.0. Okay, and it goes, and where it is last 10.255, 255, 254. This is my last one. Okay, first valid, last valid. This is the host addresses ranges. And once we done, so then what is the original last, which is nothing but a broadcast. This is a broadcast ID. And it is become 11. See, the network portion is changed. Network portion is changed. It means both are different networks. Both are different networks, right? Network portion is changed. Host portion will keep changes. Okay, it is like a sequence already I told. Like that. Okay, so it is a host. It means 2 to the power of 24 minus 2. So this is the total number of devices we can connect in this network. See, it is in first example I got only 254. I got only 254. For example, in my company I have 100 computers. Which is the best one? Class C. Class C is the best because of Class C 254 IP addresses you are getting. So it is enough for your 100 computers. Now company added one more 100. Now total 200 computers. Yes, still you can use same IP address scheme only because set maximum is 254. Now my company got a 400 computers. Class C is not suitable. What you will do? Any class B IP address will use it. So because of class B is giving 65,534 IP address in a single network. Next one is you cross 65,000. You cross 65,000. 5,000, for example, 5,000 computers. Class B. You can still use the same class, same network. 10,000, 20,000, 40,000, 50,000, 60,000. Still we can use it. 70,000. Yes, you cannot use that network. So you have to go for a class A. In a class A, you can use up to 16 million. 16 million 7,700 777,000 to 14 host we can connect in a single network. You can see this is an example. This is the class A. This is class A. Identify first which class it is. It is a class A. In a class A, network portion is first portion. Network portion is first portion. Remaining become host portion only. Host portion can be changeable within the network. It's a class B. It means first two portions are a network portions and the next two portions are a host portions. In a class C, first three are a network portions and the last one is a host portions. So here it is important is always keep it remember guys. To make a communication between two devices, okay, first they should be in the same network physically and logically, okay, without using extra internetworking. This is not a concept of internetworking. It is a basic concept of just networking. What is a networking part? First devices should be connected physically, right? Physically in a same segment, devices must be there. And when they want to communicate each other, they're logically same network. Okay, device must be in the same network to communicate each other. Device network portion must be same or network ID is must be same. Either you check the network portion or you will check the network ID. Okay, if you want to make a communication between two or more different networks, okay, for example, you have a 10 computers in the different network, logically different network. So these blue lines, blue kind of stuff are logically different network, and these are different networks. You want to make a communication. Okay, you want to make a communication between these networks. We need a separate device called a router. What is router? Router is a inter-networking device which make a communication between two or more networks. So logical and physical networks, of course, they should be separated physically. So without getting any confused, okay. So we have to logically separate them. And of course, there is some other techniques also there. That is a different point, but here it is. Physically must be different networks and logically there are already different networks. We have to use the router to make a communication between two different logical networks. Two different networks. In generally, without we are going with the inter-networking part. So we'll go into networking part. Devices must be to make a communication between devices, their network portion or a network ID must be same. Of course, physically they have to connect it. See PCA, I have two computers. First of all, PCA, so PC1 is a 172.16.10.230. PC2 172.16 100.12, and it is a class B. It is a class B. What is the network portion? The first two are a network portion. The first two means 172, 172, 16, 16 same. So these PC1, PC2 will communicate each other. Okay. Next PC3 is added again. Check the same network. So 172, 172, 16, 16. And this PC also will communicate like PC1, PC2, PC3 can communicate each other. PC4 172, 17. Different network, right? 172. First portion is same, but second portion is different. Means PC4 is not able to communicate. It is a separate network. If in case, guys, you have a 4 computers, PC1, PC2, PC3, PC1, PC2, PC3 configured, and you go to PC4, configuration is wrong. By accidentally given a wrong IP, what you have to do it? You have to change it properly. Very simple. How to troubleshoot a network? So this SOP, this one, next one, connection, remove the plug, connect the plug. Okay, not always, guys. It is not a very big deal. When you cross verify the IP address, both PCs are in the same physical network, and they're unable to communicate each other. So when you check the IP address, both PCs IP address are different network portions. What you will do it? Correct the network portions. Correct the network portion. So 3 PCs are in one network. Fourth one is different. So we can correct the fourth one. Okay. Same goes here. PC, A PC, B PC. Both will communicate each other because of their network portion is 101. CPC cannot communicate because the network portion is different. APC, BPC again, so their network portion is same to 201, 100, 100, 10. Their network portion is same. But if you take CPC in a third position, in a third octet, it is different from AB. In a DPC 101, in the second octet, which is different from A and B. And EPC, the first octet itself, it is different from A and B. So AB will communicate each other, but C, D, E cannot communicate it to A and B. Why? Because of their network IDs are different, are network portions. Okay, in at least one of the network portion is different. It may not all the network portions, but one of the network portion is different. So compulsory check the. Guys, understand network and host portions?
Yes, sir.
Okay. Yeah, for a starters, it is look like little confusion will be there. It's no problem. Just take multiple IP addresses and you can see them. Guys, we understand which is the network portion, which is the host portion. But here I said network ID must be same. Whenever a PC is communicating to another PC, so they will also, while they are using a source IP, destination IP, also there are use network ID. Are we both are in the same logical network? If both are in the same logical network, they will communicate each other. Both are not in the same logical network, they cannot communicate each other. Of course, both are must be in same physical also. Okay, so in general, in a basic single network. So what is this subnet mask? Subnet mask divide your network, divide your IP address, divide your IP address into network portion and host portion. Subnet mask will tell what is your network ID. And default subnet mask for a class A is 255, class B 255, 255.0.0, class C 255.255.255.0. These are the default subnet mask. It means whenever you are entering an IP address, this subnet mask will come immediately. So for a PC, for example, one PC is there, it is having an IP address 192.168.10.20 is an IP address. Whenever so we have to convert, enter into the binary format, and the subnet mask for this IP address is a class C, right? So 255.255.255.0. So this is IP address, binary conversion. And what we have to do is we have to do ending operation, end gate operation. You may not remember end gate. It is already there in your 10th class itself, like a truth tables. Okay, true, false, 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 true, false, false, sorry, true, false, false, true, true, true. Okay, guys, maybe your background is not electronics or computers or IT related, or you are may not studied digital electronics or binary conversions kind of stuff, logical gates. You may not study, and I want to say very simple, guys. Study. Better to study anytime, because of the logical operations are very important in a future for lot of things, for lot of things. Okay, logical operations. Okay, please try to get to know. If you have any friends, uh, uh, people in the studied electronics and communication engineering, or electronics ENTC, electronics and telecommunication engineering, CSC, IT background people, these people generally they are having basic digital electronics and logical gates, truth tables. Okay, what is that logic behind it? Okay, just you can ask them and learn. Or a lot of YouTube material is there nowadays. You can try it also. Okay. So whenever you implementing a program or whenever you are generating a algorithm, so logics are very important. That's why I'm telling. And binary and hexad system is very important. Not today, not now, but future. Okay. So here it is. If both bits are high and output is high, that's a simple 1 1 1. 1 0 or 0 1 or 0 0, it is a 0. Same it is goes. So always we will verify like a 1 1 1 1 1 1 0 1 0 0 1 0. Like this we'll do it. See here it is. Here 1 1 again 1 0 1 0 1 1 1 0 1, like this it is. Why it is meant to shifted? It is now correct. Okay, here it is same. Okay, so we'll get this one. Okay, this is my network ID. So once we are got a output in a binary, again we have to translate into decimal format. Okay, so we got this is the network ID. Don't press on this one, guys. Very simple. What is a subnet mask? Subnet mask will tell your network ID. So I calculated based using this subnet mask against this IP address. I got a network ID using ending operation. Okay. Next, subnet mask divide your IP address into network portion and host portion. So you will know what is your network ID. So based on that, you will understand network and host part. The next one is subnet mask use end logical gate to table. It is also end operations. Okay. Default subnet mask, by default, whenever you are using an IP address based on a class A or class B, class C, we have to use this IP address by default. Sorry, we have to use this subnet mask by default. 255.0.0.0, 255.255.0.0, 255, 255, 255.0. Very simple, guys. 255 represent all ones. The 1 represent network portion, the 0 represent host portion. The zeros represent host portions, 1 represent network portion. Okay, so the in a class A, first portion is network portion 255, all are ones. Class B represent first two are network portions, so then it is 255, 255. class C represent first three are network portions. So 255, 255, 255. Okay. Yeah, guys. This is IP address 192.168.10.110. That is IP address. I said an IP address. I didn't give you a subnet mask. I didn't tell you like what is your IP address? 192.168.10.110. That is my IP address. I didn't told about my subnet mask. Meaning is you are using default subnet mask. You are using default subnet mask. You didn't change your subnet mask. It's a default subnet mask. Or sometimes you can tell like this. Okay, so you are try to assign an IP address, or you have to write an IP address. You have to configure something for an IP address. In that one, compulsory you have to tell your subnet mask. So what you do? 192.168.10.110, and the subnet mask is 255.255.255.0. Even though you are using default subnet mask, in certain applications or certain areas, certain configuration, you have to write complete subnet mask. In some places, you have to give only slash notation, like a prefix, slash notation, CIDRs, whatever the word it is. So how many number of ones in your subnet mask you have to write in the slash that number of ones. For example, I have to write 255, 255, 255.0. Instead of that one, I can write like this slash 24. Why slash 24? 255 means 8 ones. 8 plus 8 plus 8, 24 ones. So if you are using a class full, means default subnet mask, generally if you don't tell also, it is understandable in some certain cases. In certain cases, you have to compulsory tell what is your subnet mask. You tell me. It is cut. My voice is cutting. Okay. Sometimes if they ask to represent your subnet mask in the slash notation. So what is your subnet mask? Based on that, you have to write it. Okay. So number of ones in the subnet mask, you have to write it. So I said class full. Class full means if you are using a default subnet mask, that network is classful network. If you change your subnet mask, to divide a network into small pieces or some different purposes also there, if you change your subnet mask, it is a customized subnet mask. So that is called a classless. Classless means if you are not using default subnet mask, that is a classless network. In a classless networks, you have to tell compulsory. In default, it sometimes may not required. But in a 1 second. Water leakage. तीन तीन 4 दिन हो गया है लेकिन वो ऊपर घर वाला नहीं है उस टाइम में, इसलिए वो
अभी तो है ना सर,
मालूम नहीं।
मैं चेक करता हूँ सर अभी। अरे ये इतना बड़ा इसलिए ओके सर, मैं चेक कर रहा हूँ।
Sorry guys. Sorry. Where are we? Last. Classless. Classless means if you are not using default subnet mask, you are using different subnet mask. In that cases, compulsory you have to tell what is your subnet mask. Writing full subnet mask or a slash notation. So these are the basic slash notations like class A /8, class B /16, class C /24. So this is different. See, this is different subnet mask. This is /25. Means this is 24, 100. This is a table you have to follow. Like this is 128 means there is a single one. So like this, see it is. This is the subnet mask, different subnet mask, and so you have to convert into binary system. So you have to calculate ones, number of ones you have to write /20. So this is /27. See it is. This is 24 and this is 3. Okay. This is a table of content, guys. At present you don't get it. Okay. Last point I will tell here it is. What is this subnetting? What is this subnet mask and changing of subnet mask? Why we should change the subnet mask kind of stuff for a subnetting? What is subnetting? It is divide a IP network into multiple subnets. It dividing a IP network into multiple subnets, small networks. Okay. So what is subnetting? Divide a IP address into multiple subnets. So here it is. If you take a network, one single network, what is the size of network? It is 254, 65,000. It is 16 million IP addresses, right? For example, I want to divide this network into small part, means two parts I want to divide. So each part will get a less than 254 means half of it. It's around 126 possible 126 host we will get it 126 IP addresses we'll get for each portion. If I divide a network a class C network into two parts a network I divide into two parts, okay, by changing subnet mask. So then I will get a 126 IP addresses per host, per network, per subnetwork. Okay, for example, same a class C network. So same class C network I divide into four parts. Each part I will get a 62 number of hosts. So number of hosts per network will changes. So network size is smaller, but we are divided one single network into multiple networks. Okay. So why we are using this subnetting part? So best utilizing IP addresses. Best utilizing. We'll say purpose is to save and better utilization of public IP addresses. We go for a subnetting. Okay. We can do based on number of hosts, number of subnet requirement. Okay, how to do this thing subnetting concept by changing the subnet mask. Okay guys, up to here. I will finish by telling this story. Okay, last part. Only two parts are there, small parts. This is a private IP addresses. This is the private IP addresses, because we don't have a time to cut again. If I put again tomorrow, again it will become late. Okay, so do not get late. So network main part is completed. Okay, so tomorrow I am going to tell about basics of PC hardware components, and also we'll discuss boot processing, basic PC components, boot processing. At the time of boot processing, what are the issues will occur? So that is I will try to finish tomorrow as possible. Private IP address, non-routable IP addresses. Non-routable means I am having an IP address, guys, right? I have an IP address. So what is my IP address? How to check? I have an IP address. This IP address valid within my local network, within my LAN network only, up to my router, not more than that one. Okay. So I have a IP address and I have a router. Okay, right? So up to this router only, this is IP address is valid. Like I can able to communicate with this IP address in my local. Okay. So for example, these pieces are connected each other. Okay. This private IP addresses, we can make a communication between these pieces. You want to communicate outside of your network, like a internet. You want to access google.com. You want to access google.com. How to access? You need a public IP address. You need a public IP address to communicate outside of your network. So this is your LAN. This is your LAN up to here only. Your main LAN network it is. It is your LAN. You can communicate each other without having any internet connection. Just we can connect. You don't require router or you don't require anything. With private IP address to communicate here, you can use private IP address. But to communicate outside, from here to outside, you want to communicate, you need a public IP address. Okay. So what are the private IP addresses are given by IANA? So anyone can use it. No need to take permissions. No need to purchase any IP addresses in these ranges, because these are all private IP addresses only. Okay. Public IP addresses you have to purchase. Private IP not required to purchase it. Class A, Class B, Class C. 10.0.0.0 to 10.255.255.255. This range of IP address means entire 10 series. Exactly say entire 10 series is private IP address. So if you use 11 series, 11 dot something dot something dot something, it is again public. So 10 series is your private. Class B 170.16.0.0 to 170.31. It means 172.16, 170.17, 172.18, all networks. 172.16.17.18 up to 31. These are all private IP. If you use 32, public. If you use 15, public. Okay. 172 is not changing, but 172.16.0.0 to 170.16.255.255, one network. 170.16. 172.17 is a different network. but private network. So class C 192.168.0.0 to 192.169.255.255. It means again same 192 168 means you are already private network. 0.1, 0.2, 0.3 like that will go on, right? So from 0 to 255. Next 1, 2, 3 till 255. Okay, different networks. This is one network, this is another network, this is another network. Because it's a class C, 3 portions are network portions. See, this is only one difference. 1, 2, 3, 4 up to 255. This entire series of network belongs to private network. Then what is this private IP addresses and what is the public IP address? As I said, you want to communicate in a public, you need a public IP address. You need a public IP address. Okay. So in generally, our internet service provider, our internet person will take care of your public communications. Okay. Next. So guys, you have a server in your network. You have a server in your network. For example, it is a kind of some web server, some web application server. Okay, it is a server. You are also in the same network, same LAN network, local network. If you are okay, you are a client, you are in a same network. So you are trying to communicate this one. You are trying to open this website. So that is called a intranet. That is the internet. Both are in the same network, same physical and logical networks. It means it is a intranet. This is a server, right? Someone outside of your network, means someone is in the internet, want to access your server. Okay. So how they will access? If you have a public IP address, so this person can able to access. If you don't have a public IP address, this person cannot access. Understand? The public IP address, if you assign a public IP address to your server and you are connected to the network, means public network, then directly people can able to access your server. Let's understand what is the use of this public IP. In generally, in organizations, what they will do it. So this is assigned with some private IP. For example, 192.168. Something 10.50.52, something like this. Okay, they assigned an IP address like this. This is the private IP. This person want to try to access this, he cannot access. Why? Because it's a private IP. All communications, right? So we'll go through this router part. Okay, so in this router, we use a technique called a NAT technique, network address translation technique. In this one, what I am doing is to mask my original IP address. So I take my IP address 52, which is my local IP. I map it to public IP, like a something like a can use simple like a 101 34 56 22, something like this. I purchase a public IP address, but I didn't assign my public IP address to my PC. My PC having its local IP address. Okay, but I have a public IP. So locally we are communicating with a local IP address. but when you are communicating outside with this one. For example, again, this user send a request, that request reach up to your router, okay, and they send a request with this one only. I want to communicate this server. I am sending a request to this server. He's sending, he don't know your private IP. You'll send a request to your public IP. And this device, a router, already having a list, right? NAT. So it is translate and forward the packet to like this with this IP address. So client is accessing our server with this public IP address, with this public IP address, okay, but server receive a packet with its own IP address. So where it is translating here, this is called a network address translation. It map internal IP address to external IP or private IP to public IP. So you have an IP address of a server and you have a public IP address. So we'll map here. So no one knows what is your private IP or whatever the IP of this configured server directly. People know this public IP address, so they will try to communicate with that one only. You try to find a google.com, like a ping to google.com, then you will get some public IP address. But originally the Google server may have a different IP internally. So we are only getting publicly announced public IP addresses only. Guys, this is called a NAT, network address translation. It maps internal or a private IP addresses to external IP addresses. Like a number of servers you have, that many number of IP addresses you have to purchase. For example, you have a 10 servers. So then 10 public IP addresses we required in this technique. Okay, in this technique. Guys, understand NAT? Very good. I have a multiple computers. This time not servers. Okay, this time not servers. I just have a multiple computers. What we are doing is all are normal computers only, but still you want to get connected to the internet, you want to access to the internet, okay, you need a public IP. I cannot purchase a public IP for each and every PC, right? Not everyone can purchase it, right? If it is an organization, big company, they will buy it. Okay, scientists may have a public IP addresses for their own servers. Okay, for internally they use normal network, but for servers kind of stuff, leased lines kind of stuff, they use their own IP addresses. Public IP address. Again, public IP address. So this is the APC. APC want to communicate outside, it need a public IP. Again, BPC want to communicate, that is also need a public IP. Okay, whether you, for example, you configured a private IP. For example, you configured private 192.168.1.11. This is 1.12. This is 1.14. This is 1.17. CPC. This is DBC. Okay. So first three are same. First two are same. 192 series. Okay. 192 series it is. So here it is. So this is a different private IP addresses are there. Using private, we cannot able to communicate. So what you have to do it? I have to do NAT technique. Then I will put it like this: 192.168.1.11, one IP address. then one public IP address, 1.12, one another public IP address, 1.14, 1.17. Like I have 4 computers, 4 public IP addresses required, right? You have to purchase 4 public IP addresses. So what the people are doing here, it is they started a technique called a PAT technique. What is this PAT technique? I have a multiple type of IP addresses, 192.168.1.11, 1.12, 1.14, 1.17. For all these 4 PCs, one public IP address only. For example, 101, 20, 40, 32, something like that. Only one public IP for all 4 PCs. Earlier I said 1 to 1. One private, one public. Now all on one. It means I'm overloading multiple IP addresses on single public. I'm overloading multiple private IP addresses on a single public called a NAT overload. Called a NAT overload. It is also a NAT technique only, but we are overloading on a single public IP address. That's it, NAT overload, also called as PAT. How it is used? It uses a port technique, port address technique. Look at here. These are the 3 private IP addresses, single public IP address. The first one is trying to communicate outside. It assign a port number on it, and same port number is mapped to this public, and it will forward the packet. Okay, so it use the porting like this is a something number. This is okay to identify to mapping for a mapping between this IP to this IP, this IP to this IP, this IP to this IP. It uses some port technique. Okay, advantage is when you are communicating outside, like a B is sending a packet. B IP address is 1.11. So while it is sending, it sends with this IP address. Of course, there is a hidden port number is also there. It reaches the destination. It reaches the destination. Destination giving reply, and we got it back. What are the requirement? And it is again the IP address changes, and we received a packet to us. Okay, but in this process, any user in the network, like this is a user want to access your PC, either your PC is a server or normal PC. This outside user want to access you, he cannot access. Why? Because of he try to send a packet to your public IP address, to your public IP address on his own. On his own is sending a packet so to your public IP. And but public IP is belongs to several private IP addresses. Which PC your belongs to it? No one knows. No one knows. Okay. If I am forwarding, the packet is going from inside to outside. So there is a mapping is happened. Once we received, log will be deleted. For example, I will show here it is. When I'm sending, this map is happened and packet will be forward. When I received a packet, okay, this mapping, okay, I will forward the packet to this PC. Once completed, I'll remove these records. Okay, record must be there. Record will be created when I'm sending a packet. Record will be deleted after I received a packet. Okay, but here it is directly a packet is came to your part. So then this is not understandable which PC is making it. So you cannot receive the packet directly. This is the PAT technique. We are using a broadband connection. So our internet, our internet we are using is PAT technique only. So using the PAT technique, guys, in India we are saving a lot of IP addresses. as compared to the big countries. But we are all using a lot of IP addresses, use a lot of devices as compared to other countries. But still we are saving a lot of IP addresses using a pack technique. We don't give like a as per like some people try to copy US based movies. Okay, even there also some faults are there, but we are copy the fault kind of stuff. Like find out his IP address, we'll track. My IP address is 192.168.1.29. Okay, this IP address is available in this world for so many people. Millions of people are using the same IP address. Okay, how people can able to track this particular based on the particular IP address. Even if they know my public IP is not generally configured to my router. My router directly won't configure with the public IP in the regular internet communication. Where it will be configured, which is handled by internet service provider. This will be handled by internet service provider like Airtel, BSNL. These people are then Geo. Those people will handle this public IP address communication. Of course, any cyber crime is happened to track back. So we can reach up to internet service provider and ask for a previous logs, but it will take a lot of time to dig exactly where when the packet is transferred, when the attack or maybe a transfer is occur, something like that we can find it. But that is again immediately have to react and go to the ISPs. Otherwise what happened, the logs will be deleted after a few days, maximum 24 hours to 60 days. They'll keep it up to 60 days also, they will keep it. It depends upon this. Okay, so this NAT address translations logs will be created inside a log server. Okay, so for in and out communication. So any cyber crime is happened, so police will go to this logs also to find it, but complaint must be filled in immediately. Okay guys, this is a NAT and PAT, network address translation, port address translation. Same thing I am explaining here. You know what is APIPA already, so I'm not going with that. That's it for today guys. Maximum network part is completed. Find out what is VPN, what is proxy also. Okay, that's it for today. Any doubts or anything? From last half an hour I'm keep asking guys. Okay, no problem. No doubts. Okay, then good. So we'll meet you tomorrow again. So tomorrow I will try to change the timing little bit early, like at 10:15, 10 o'clock. 10:15 means it become 10:30. If I said 10:30, it become 10:40. So that's why we'll see. No problem. Tomorrow we'll see. Okay, guys, study well, study daily. Okay, study daily. Go through once again 2-3 times. Not watching your videos. I'm not talking about watching your videos. Go through the materials. Okay. That's it for today. Thank
Sir,
you.
I
Bye bye.
have doubts.
Yeah, tell me then.
Sir, what is the difference between this APIPA and link localize? Both are assigned when there is
Actually,
assigned
that
by.
is very good doubt. That is
Sir,
very good doubt. That is very good doubt.
okay.
Okay. Yes. Very good doubt. Guys, APIPA, automatic private IP address. So you have a PC. You try to get IP address from DHCP server, right? And you are unable to get. What happened? PC assign itself an IP address an IP address in the series of 169.254. And there is one more comparison is also there. And what is these two parts? Another two octets, 169, 254 common. But how these two remaining parts will get it based on your MAC address. Based on your MAC address. The thing is, if you fail to get an IP address from DHCP, PC configure itself an IP address with 169.254 something based on your MAC address. That is a APIPA address. And what is link local? Link local again, it's a kind of APIPA only. So some similarities, some not similarities also there. Link local is again, it is belongs to IPv6. You have an adapter. You have an adapter. For example, you are using IPv6. IPv6 IP address you will receive from some resource like a IPv6 DHCP server type or stateless mode kind of stuff. You will receive an IP address from the router or a DHCP server generally. Okay, or you can configure manually. Either you will configure manual or automatic. Whether you are having an IP address, whether you are having an IP address from DHCP server or manually configured. Either way, your adapter, your NIC card having a MAC address, okay, with the help of MAC address, our PC creates for this adapter, only for this adapter, only one adapter, okay, for this adapter, for this only one IP address. For this adapter, it creates an additional link local IP address. First FE80 series, colon, the remaining portion based on your MAC address, it will be created. This is the only one IP address per adapter. Even though you configure your IPv6 from DHCP server or manually configured or not configured, whether you configure or not configure IP address, this IP address is already there. I will show you that. So got a doubt means either you understand or you know the subject, right? That's a good one. Oh, what happened? Large icons, first icons. What happened to this? Network and sharing center. Change adapter settings. Normality shows better way, right? So that is showing like this. This make me irritation. I'm going to this VMnet2, no problem. So this is my MAC address. This is the APIPA address. Why? It is try to get IP from DHCP, but it is failed. This is a link local IPv6 address. This is also assigned by system. This is also assigned by system. But APIPA is invalid. You got APIPA, you can't communicate. So one more is there. That is, you have a PC and you got APIPA. You have another PC. If you want to communicate each other, you cannot communicate. Even both are APIPA, also may not be communicate. So there is no guarantee they will communicate or not. But if the PCs in the same LAN network, all PCs can easily communicate without any direct IPv4 address or direct IPv6 address without IPv4 assignment, without direct IPv6 assignment. So how they will communicate? Using this link local IP addresses. Link local IP address is not assigned by user, it is assigned by system only. But we can communicate using APIPA. We cannot communicate using this one. See, what is this? IPv6 properties. So obtain IP address automatically. Use following IP address. So I'm assigning a IP address manually here. I'll do like this. Something I put it IP address. Do not worry. Default gateway not required. Just click close, close, close. Again, check it. So can you see IPv6 address? Even I assign an IP address. Link local IP address is there. Link local IP address is the IP address given by system to our adapter. Okay, this is I given IP address manually, or if you got IP address from DHCP for IPv6, but still you will have a link local. Okay, but this is not like that. For example, I will assign an IP address because I don't have any DHCP here. No, not this one, like IPv4. So in IPv4, I'm changing my IP address, like I put a 10.10.1. Something like this. Remaining is okay, no problem. Look at where is APIPA address? Okay. Once you are having an IP address, either manually or dynamically, APIPA won't be there. You fail to get IP address from DHCP, APIPA will be there. Okay, that's the first point. Okay. Second, in IPv6, either you got an IP address from DHCP server or manually configured, your link local IPv6 will be there. So can I repeat again? In IPv4, either you configured manually or you got IP address from DHCP server, you are not having any APIPA. Only you fail to get IP address from DHCP server, system assign an IP address in the APIPA range. And this APIPA address you can't use for communication. Just it's an IP address for decoration purpose. Of course, if all PCs are APIPA, maybe we'll try to communicate. Okay, so I never seen that kind of stuff. We tried also. Okay, next in IPv6, whether you are having an IP address dynamically or manually, you got an IP address, you will have a link local IP address generally. Link local IP address is also generated by system using the MAC address of your adapter. Okay, link local IP address is valid within the LAN communication. Within the LAN only, without having any IPv6 address or IPv4 address. Using link local IPv6, we can communicate each other. We can share the data also. We can access the things. Okay, guys. Understand?
Yes, understand.
Okay, good. So that is a very good doubt. Normally we'll tell, but it will give more headache. That's why we don't tell. That's a good one. Thank you, guys. Meet you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you.